In 2005, a group of space engineers, science journalists, writers and enthusiasts founded what would become Interstellar Technologies Inc. Initially operating under the name Natsu no Rocket Dan or Summer Rocket Group, they set up their headquarters in Taiki, Hokkaido, Japan in 2013. They started on the journey to build a space company from nothing, slowly making progress towards their vision. The breakthrough came in 2019 when they launched the first privately developed Japanese rocket to reach space, followed by 2 successful space launches within the same month in 2021. Space is on the cusp of becoming a big component of Earth's economy, with space activities becoming increasingly routine. Interstellar Technologies aims to succeed in the launch market by flying low-cost rockets frequently and strengthening Japan's position in the global space market. Interstellar Technologies has made significant strides in rocket technology, particularly with their engine designs. Given that engine costs typically constitute half of the vehicle's total cost, minimizing these expenses is crucial. They pioneered their own wire wrapping manufacturing technique, which cuts down on both lead times and costs. By enhancing the traditional pin-tunnel injectors, Interstellar has managed to reduce the number of components needed while maintaining high combustion efficiency. Additionally, Interstellar has crafted an in-house turbopump system, leveraging 3D printing technology to its fullest. They've also advanced aluminium welding techniques, which further drives down cost. And finally, their development of proprietary avionics hardware and software completes their suite of technologies aimed at cost reduction and performance enhancement. MOMO Suborbital Sounding Rocket. MOMO is a suborbital launch vehicle that reaches an altitude of about 80 to 100 kilometers before ballistically falling back to Earth and splashing into the ocean. It is used not only for scientific experiments that take advantage of the microgravity environment, but also for PR and branding missions. The MOMO vehicle has launched 7 times so far, and the latest version of this vehicle has a 100% success record. It's a low-cost sounding rocket that can be used for science. MOMO can reach an altitude of 100 kilometers, that's 62 miles, is 10 meters tall with a mass of 1,220 kilos. The thrust produced by its single engine is 14 kilonewtons, and the propellant is liquid ethanol with liquid oxygen as the oxidizer. Zero, the orbital class launch vehicle. Interstellar Technologies ensures small satellites reach their desired orbit with flexible space transportation services, including both dedicated launches and rideshare options. Their advantages, according to their website, are on-demand transportation suitable for larger satellites that can't make use of shared transportation, such as SpaceX's transporter and bandwagon solutions. Because of Interstellar's in-house design and manufacturing capabilities, they can offer flexibility and adapt to the specific requirements of their customers. Interstellar Technologies offers one of the most competitive price points in the small satellite launch market. They achieve this by actively employing cutting-edge technologies like consumer-grade components and 3D printing. The Zero rocket, a 2-stage vehicle, offers versatility in destinations, spanning from low inclinations to polar orbits. This flexibility ensures that the launch vehicle can meet a wide range of mission profiles, making it an attractive choice for satellite operators worldwide. Let's look at the specs. Zero is an orbital class rocket that can place payloads into low Earth orbit, stretching 32 meters in length with a diameter of 2.3 meters. This rocket has the capacity to deliver 800 kilos to low Earth orbit and 250 kilos to Sun synchronous orbit. The total weight of the vehicle is 71 tons. The Zero propulsion system uses liquid methane as fuel, paired with liquid oxygen as the oxidizer, a combination gaining popularity among space startups. Why do space startups like to use these propellants? Well, methane burns cleanly, leaving minimal residue in the engines, which simplifies the process of engine reuse, a critical aspect for reducing launch costs. Additionally, methane doesn't demand the ultra-cold storage conditions that hydrogen does, simplifying both storage and handling. Moreover, being essentially refined natural gas, methane is both cheap and readily available, making it an economically sensible choice for startups. One note on reusability. Zero, at least initially, won't be reusable. But Interstellar has plans for a bigger rocket that will be, and Zero may become reusable at a later date, especially if the market demands evolve. The structure of Zero reflects a balance between strength and weight. The payload fairing is constructed from carbon fibre, offering durability with a reduced weight. However, for the tanks of the first and second stages, aluminium is the material of choice, providing a robust yet lightweight solution for containing the propellants. Each engine in the Zero rocket produces 130 kilonewtons of thrust, including advanced technologies like regenerative cooling and turbopumps for enhanced performance and longevity. The fuselage, which includes the tanks, engine section and interstage, features a composite construction of carbon fibre and aluminium. This design not only provides the structural integrity required for the rigours of spaceflight, but also minimises the overall mass compared to using aluminium alone. Decker Heavy Lift Vehicle. Decker aims to meet the increasing demand for more mass to orbit. This can be seen in the number of customers wanting to launch constellations of satellites. A larger launch vehicle is needed to efficiently place these satellite constellations into orbit in a reasonable time and for an affordable price. Decker is positioned to provide deployment of satellite constellations, launch large satellites into orbit, deliver supplies to space stations, and conduct interplanetary missions. This vehicle will make full use of the low-cost design concepts from Zero, and in addition will have a reusable first stage. Let's go over some of the key milestones for Interstellar so far. In May 2019, Momo Flight 3 became the first privately developed Japanese rocket to reach space. After failures of the Momo rocket in 2017 and 2018, the third flight of Momo was successful, making Interstellar the first Japanese company to design and build a rocket to reach space. The company has upgraded their Momo vehicle, and the latest version now has a 100% success record. Flight 6 and Flight 7 flew successfully in July 2021. In September 2024, the Japanese government awarded Interstellar Technologies a grant of 4.63 billion yen through the Small Business Innovation Research Program. This program seeks to encourage the practical implementation of innovative technologies developed by startups. Interstellar has previously been selected for the first phase of the project in September 2023, where they received a grant of 2 billion yen. After passing a review, the company progressed to Phase 2, unlocking this larger funding opportunity. The demand for space launches has been increasing, but the supply of space transportation services has not kept pace, leading to challenges for satellite operators and inflated launch costs. In Japan, the scarcity of launch opportunities, with only a few conducted each year, has forced many local satellite operators to seek services abroad. To counter this, the Japanese government has set an ambitious target of achieving 30 domestic rocket launches per year by the early 2030s. This initiative aims to meet launch requirements both within Japan and on the international stage, using both governmental and commercial launch vehicles. And finally, for milestones, in November 2024, Interstellar started construction of its new Tohoku branch in Fukushima Prefecture. This facility will play a pivotal role in the development and mass production of Zero, their orbital-class launch vehicle, which is gearing up for its first launch. The Tohoku branch is designed to streamline and boost production capabilities for both electrical and mechanical components of the rocket. It will also feature advanced testing facilities for avionics integration. Alongside production areas, the branch will include office and warehouse spaces, initially accommodating 30 employees. Interstellar plans to hire locally to fill some of these positions. The construction is expected to conclude by November 2025, with operations commencing the following month. Upcoming events. Interstellar continues to launch its Momo suborbital rocket while ramping up production to mass produce its Zero orbital rocket. They have scheduled the first flight of Zero for 2025, but delays are common in the space industry, so we'll just have to keep an eye on that. We're rooting for the success of Zero and are excited about Decker, the heavy lift vehicle that will follow. Stay tuned for updates on their progress. Okay, that's it for this video. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon!